We are live now. Good day to all. Welcome you all to Saveetha International Architecture Talk Series conducted by Saveetha College of Architecture and Design, Saveetha Institute of Medical and Technical Sciences. Today's talk will be the seventh talk of the series. I am Dr. Deepak, Associate Dean International Affairs, Saveetha School of Engineering, Saveetha Institute of Medical and Technical Sciences. At the outset, I extend my sincere thanks to our Honorable Chancellor, sir. I also extend thanks to our Director, Madam, for Madam's continuous support, guidance, and motivation. Today we have with us Dr. Alejandro Veliz Reyes from University of Plymouth, UK. He is going to present on the topic Creative Innovation and Digital Fabrication. University of Plymouth had signed a memorandum of understanding with Saveetha Institute of Medical and Technical Sciences already. Student exchange program and research collaborations are carried out between both universities for a long time now. I'm sure today talk will also open up new opportunities in the field of architecture and design. Now I invite Dr. Balsava, Dean, Saveetha College of Architecture and Design, Saveetha Institute of Medical and Technical Sciences, to give his welcome address. Over to you, sir.
Thank you, Dr. Deepak. It's really an honor to invite Dr. Alejandro Reyes for this very significant talk on a theme which is very critical to our times today: creative innovation and digital fabrication. This theme has become even more important with the kind of physical distancing and the fact that we are moving at a faster pace into the digital and the virtual world. Professor Alejandro has a vast experience in this area, and we look forward to the talk. After the talk, there would be a small discussion we could have after the talk. It would be for an hour. And welcome, Dr. Alejandro Reyes. We are really happy to have you. And we hope that this is really the beginning of an exchange, a deeper exchange between Plymouth and Saveetha architecture, both on the digital as well as we hope to invite you down to our campus in Chennai soon. And we hope the lockdown is removed at the earliest. I would invite now architect Sandhya to introduce our speaker for the day, and then I would invite our speaker to present his talk. Thank you.
Thank you. I'm happy to introduce Dr. Alejandro Veliz Reyes, an architect and lecturer on design and fabrication at the University of Plymouth, where he leads the postgraduate course MA and MSc Integrated Design Innovation with a focus on the delivery of digital solutions to industrial challenges. Additionally, he is an associate tutor at the Research Cluster Architectural Production at the B. Pro M.Arch Architectural Design at the Bartlett School of Architecture. His research addresses the development and study of cyber-physical systems in creative practice, with a focus on the material and social context of design. Throughout his career, he has investigated the use of augmented reality in design studio teaching, the development of prefabricated building components for low-income housing, and the use of robotic technologies for creative 3D printing applications. His research grants include funding from the EPSRC, Research England, and professional bodies such as the Chartered Institute of Building, and projects have been delivered in partnership with the Cardiff University, the Technology Development Corporation of Chile, and the EPSRC Connected Everything Network. Currently, he is an academic advisor of EPIC, eHealth Productivity in the Isles of Sicily and Cornwall, and an automation fellow of the Southwest Creative Technology Network, where his project has developed a partnership with the School of Engineering, Computing and Mathematics, and Epson Robotic Solutions to scope the creative applications of industrial robotic arms and the development of an open source framework through the robot operating system for Epson robotic equipment. Here he's going to present on the topic Creative Innovation and Digital Fabrication. We are very happy to have you here. Please start with your presentation, sir. Thank you.
Thank you very much. Thank you very much, everyone, for the invitation and for your time. It's really incredible to be here today. So, thank you very much. Before we start, I'm just going to turn off my background because it seems like it's consuming a lot of my bandwidth at the moment. And just a second ago, WebEx stopped working on my laptop. So hopefully everything will be okay as I present. But my apologies for that. So my name is Alejandro Veliz Reyes. I'm an architect and I'm a lecturer in digital design and fabrication at the University of Plymouth. And I'm going to talk to you about a series of projects, but all those projects address elements of digital fabrication in production, particularly in architectural research, but also stemming across other fields such as product design and the arts. So it's a quite multidisciplinary work that I do, and largely the focus of my role is to look into the links between creative thinking and design methods and other disciplines. So I have built links with areas such as manufacturing or robotics or computing, as you will see in a second. And that is also the heart of what we do in my own master's, which is a master's in integrated design innovation, which I'm going to talk to you a little bit at the very end. My role encompasses a series of activities, so it's not just research, but also teaching and also industrial partnerships. So the work that I do sometimes involves outputs which are more artistic, if you wish. You know, they address elements like exhibitions or installations, but in some other cases we conduct more technical research, if you wish, through academic journals and experimental research that I'm gonna show you in a bit. But probably something that encompasses my work in a very broad sense is the study of digital systems, and particularly with a focus on materials and production. How do we make things using digital media, and how do we produce things by looking into those intermediate spaces, right, between digital media and physical production. So I have worked with robots that 3D print, or robots that draw, or 3D printing with students, or a series of other kind of industry partners that you will see in the upcoming images. That involves either elements of product design, if you wish, more open-ended experimental studies. This is an example of robotic clay 3D printing that you will see in a second, up to more speculative, spatial, architectural, large-scale applications as well. So I have worked across a range of scales as well, and technologies that involve not just 3D printing, but additionally elements of coding and manufacturing and so on. At the moment, part of my work is supported by the Southwest Creative Technology Network, which is a Research England funded network in the southwest of England that covers 4 universities and 3 industry partners across the region. And what they do is to fund a series of fellowships, and I am an automation fellow of Research England, looking into robotics, as well as links with industry partners through this network in order to facilitate local growth and business support in the region. Part of what we are busy now building, probably you might have seen, or you might be familiar with some elements of our School of Design. This is our building, and at the heart of my work at the moment is the delivery of in the heart of our building, our new digital fabrication and immersive media laboratories, which involve not just a series of equipment to facilitate prototyping, model making, and so on. This is an architectural model we produced with a local company a couple of years ago, but additionally to bring industry partners in, and particularly to work in partnership with local businesses on the delivery of collaborative research that involves not just prototyping fabrication resources, but also an immersive media lab that includes some resources such as motion capture technology, immersive visualization, or long-range 3D scanning tools. So we have a lot of toys, and we are now setting up the lab so we can, start operating with local businesses, conducting collaborative research. Additionally to that, I have an associate tutor role at the Bartlett at the University College London, where I support the research, the theory submissions of a research cluster of students, a research cluster called Architectural Production, that this semester has been looking at incremental metal sheet forming using robotic technologies for architectural applications as well. So my work ranges across a number of technological applications, let's say. But what is interesting about my role is that it's a bit more open-ended and it's very flexible, although I'm going to show you the work I did in an architectural design studio as well. But it sits in between this approach to design and creative thinking that acknowledges, obviously, the value of the arts and design thinking, as well as leveraging opportunities arising from STEM approaches and the use of certain resources and technologies that typically, right, originate on the STEM fields, such as computing or engineering or robotics, right? That approach that stays somewhere in between, right, the STEAM approach, as it is typically called, is the acronym for STEM plus arts and design. And this diagram is very useful for me because it can help me position and situate a little bit the different things that we do in the context of this gradient, right, between STEM disciplines and art and design disciplines. So you will see this diagram coming back a lot throughout the presentation as well. This is quite interesting. This is a case for STEAM education. Really, this is data from Scotland indicating that there is actually a quite high percentage of young people that actually do select STEAM A levels in school, right? They mix and match both STEM and arts and humanities subjects, and there seems to be a quite interesting ground, right, of young people who might be interested in exploring more multidisciplinary areas. However, what we tend to do, given the limited length of our degrees, is to funnel them through quite specific degrees, which sometimes do not acknowledge the richness and the complexity of the professional interests of young people. So this is actually made with data from Scotland by Nesta, looking at STEAM subject combinations in high school. And of course, there is also a broader institutional and government drive to look into STEAM subjects, not only because they're a good thing, but actually there is an evidence that companies that make that utilize a mix of scientific as well as creative thinking approaches outperform those companies that use only technical or only creative approaches. And there seems to be a bit of a raise in awareness lately about the fact that the arts and more broadly the creative sector and the design economy can provide a series of transferable skills to facilitate processes and ways of thinking in other disciplines as well. So the first thing I'm going to show you sits quite comfortably there in the middle. It's called the Fab Studio. This is a studio that I run for 3 years in our School of Architecture. Fab comes from Fabricate. And it's a studio that was particularly focused on the operation of digital technologies in the context of architectural design, not only from a perspective of design, model making, 3D printing, and digital practice, but also using digital technologies as a way to better understand and analyze certain urban or site or material sort of contexts of practice. So it was quite hands-on. We were looking into architectural production, not always from a digital perspective. So we actually conducted lots of material studies and tests that involve not just mixing materials, but trying to outline the opportunities and the material challenges associated to different architectural responses to those modes of production. This is a material study in concrete and fabric by our student Lucy Daw from a couple of years ago. And of course, typically something that stands out from that process of continuous prototyping and iteration is the framing or the reframing of what constitutes a model, right? A model not just as a representation of space, but a model as something that can help us prototype and iterate material approaches to architectural design and architectural thinking. This gorgeous model is part of a museum in one of our study trips to Amsterdam. Of course, innovation in material system comprises a lot of case studies. So it was we typically had a quite intense study trips looking into different cities and buildings and case studies, not just to look at the material and spatial complexities of some buildings, but actually to see certain well-known pieces of architecture and analyze them. This is the Mercedes-Benz Museum by UN Studio in Stuttgart. This is particularly a facade detail made in some quite spectacular kind of concrete casting techniques. And then, of course, how do we look at the wider city? How do we look at the model as something that can help us better understand those site, right, and urban dynamics, right, from a material prototyping sort of perspective. This is from the Museum of the Canals in Amsterdam, and two of my students playing around with the exhibition. A really interesting example of the prototyping of the built environment and to what extent models become a delivery strategy for architectural compositions is NDSM, which is an old warehouse in Amsterdam, which has been populated with experimental architectural spaces by the users. It's a bit of an architecture without architect situation. However, it's really interesting how this whole massive warehouse in effect becomes a prototype of a urban space through the delivery of quite particular low wave and simple to build really material systems in the context of design and craft fair, right? All these little installations that you see there are typically populated by design officers and local designers looking into the production of, their craft next to an area which is one of the largest crafts market in Western Europe. And here you can see as well a quite interesting and short video that we made with some students. Well, some students made actually in Turin when we were in our study trip in Italy, looking at not just the production of space, but actually the use of digital tools and digital media as a way to address certain neighborhood and spatial issues from a slightly more analytical perspective. So you can see a series of not just combinations of media, but also you can see a series of models, which are actually quite interesting ways to conceptualize and deliver a sense of abstraction, if you wish, when we think about issues, for example, density or building height or building density in certain areas, right? And this was part of our, let's say, working methodologies. Eventually, these courses, of course, as you can probably guess, rely heavily on the study of model making and material approaches to the delivery of architectural responses to space. So our models were typically, relatively complex with a lot of iteration and quite dense agendas around prototyping and making to inform different projects. And the resulting projects were quite sophisticated, at least from a material, right, and prototyping perspective. This is the work of a second-year student looking at free-form timber structures to facilitate zenithal light solutions for a library in Plymouth city center. And this was the design of one of our third-year students looking into this use, not use containers as an opportunity to deliver new innovative material systems for architectural responses. This project by the student Greg Wotton was actually one of the representatives in our school and nominated for the RABA President Medal nationally. So it was a quite sort of successful approach to our design sort of agenda. Going back to this diagram, my research looked into those certain elements of prototyping, digital fabrication, but eventually evolved into robotics and robots making things, particularly because robots are slightly more flexible, right? You can attach different tools and do different things with robotic arms. So this little workshop was our first collaboration with the School of Engineering, Computing and Mathematics. and it was a workshop on robotic art that, of course, is led by robotic technologies, but yet again, looking into that artistic, creative drive behind what we do. So again, it sits quite comfortable in that kind of space in the middle. What we did is to win an international competition by Epson Robotics. We were quite lucky to be the only team from the UK that won a series of robotic arms nationally. That was last year. And what we did with our colleagues from the School of Computing was to start developing certain interfaces and ways to operate those robots, which are a bit more open and a bit more flexible instead of using Epson proprietary language, let's say. And what we did was to implement these robots into an open source system called Robot Operating System, or ROS. And that would allow us to operate them in much more flexible ways, but also attach to these robots different libraries, right, of components that involve more advanced technologies such as sensing or artificial intelligence or computer vision, etc. I'm not going to bore you with the details of the code, but we did develop this code in-house in order to speculate a little bit and look into how robots can engage with a process of creative production. And the simplest process we started with at this point in time was the process of drawing something, right? It's a b-dimensional task. It's not three-dimensional, so it's slightly more controllable, if you wish. And we implemented this system as part of a summer school with a range of academic partners from China. And in this summer school, we receive around 25 students from these three universities, Nanjing, Jiangnan, and Suzhou. And what we did was to conduct a joint workshop with the School of Engineering, which at the time was the very first joint summer school across both faculties, in order to achieve this, right? Human robot collaboration. How do we reframe and understand questions of robots producing art, and what is the role of humans and the role of, you know, the machine within those emergent, more technologically advanced modes of creative practice. In order to achieve that, we started speculating a bit about whether robots could replicate human art or not, and we ended up with really simple experiments like this. One of these images was produced by a human, and another one was produced by a robot, trying to imitate certain patterns or certain highlights or certain features that you could see, right, in the human artwork. So you can probably guess, right, that the left image is slightly more complex and uses more colors and has a bit more fine detail that was made by human. And the right image was an attempt to replicate it by a robot. This doesn't only involve the coding and the bespoke software that we develop in-house, but additionally, it involves the design, right? The engineering design of the tools and ways of supporting and holding pens and brushes and so on by our students. So it was a quite interesting process of development and prototyping and iteration, trying to understand how a robot could eventually draw. And we conducted this through a 3D printing workshop using our lab's facilities. Eventually, you end up with things like this, right? With tools that can hold different brushes or pens, sorry, in different ways. But more relevantly, you start understanding certain patterns of creative practice when you would see students trying to engage with robotic production in quite interesting ways and trying to, in a way, collaborate, right? Enable these kind of very simple processes of human-robot collaboration. And we ended up with things like that. This is a quite complex drawing for a robot to process, given the fact that it has gradients and complex shapes and quite a complex, graphic composition. And the robot gave it a try. It's not perfect, but you can, of course, identify certain features, right, of this human image on the left. You can identify that on the image on the right. At the moment, we're actually applying the same, similar technology on the delivery of three-dimensional media, not just 2D media, and we are in the process of delivering a bespoke kind of intelligent nozzle to extrude clay in those robotic arms as well. And you will see in a second some work we have done in that space as well. Again, a reminder of the diagram, and I'm going to show you now our next project, which is called Computing Craft. This is an interesting one. It's a project that addresses knowledge, right, which is developed outside the institutionalized modes of knowing that we have. You know, what do we do with knowledge that doesn't come from STEM or from the arts, but comes from people making things in, you know, in their lives? And how do we bring in that knowledge, and how do we leverage that in order to find technological development opportunities and new lines of research by trying to better understand the nature of that knowledge? So what we did in this Computing Craft project is to work with a material called cob, which is a mix of mud and hay and clay, typically used in ancient constructions, but quite typical and prevalent in the southwest of England as well as northern France. Although you can find, of course, variations of earth construction all around the world. And what we were looking at is a framework that would allow us to think about this, what some colleagues might call a vernacular mode of construction, right, or an historical mode of construction, and trying to better understand how to access that knowledge, right, and how to facilitate and enable new lines of research and technological development from techniques and traditions which are usually developed outside the boundaries of academic and professional sort of frameworks. To describe this a little bit, that kind of theory background, if you wish, we did deliver a paper last year. The quote is there on the bottom left on Architectural Science Review on how to explore from a digital perspective what we called craft-driven innovation. Because this is what you might sometimes find in the literature, isn't it? Like building with cob or building with mud as a quite kind of DIY activity, something that is relatively simple, when actually cob and mud and clay are actually really, really complex materials, and they require a quite phenomenal level of skill, really, in order to deliver architectural solutions which work, which are safe and that are kind of well built. So in order to address that, we first of all secured a little grant from CIOB, that's the Charter Institute of Building, in order to characterize cob as a kind of digital material, so we can kind of embed cob in existing frameworks of data and design management, like BIM, right? This is a screenshot from Revit, actually, where we kind of characterize cob through a series of literature reviews, and we were able to identify and source in the literature both physical and thermal properties that would allow us to actually, first of all, and to begin with, you know, identify cob as a material that we could model with, right, and simulate. From this point onwards, we partner up with Cardiff University and the Welsh School of Architecture and a PhD student from the University of Adelaide in Australia. And we secured some funding from the Engineering and Physical Sciences Research Council through the Connective Everything network, which is really interesting because we were the only team of designers receiving funding from the Engineering Research Council for this specific call. So it was a quite interesting exercise on multidisciplinarity, if you wish. And this was our methodology, right? First to kind of prototype small scale elements, either digital models or look into the extrusion systems that might be required to work with cob. Cob is really complex because it has stone. If you wish, it's not like concrete. Some kind of videos or that is very paste-like. It's almost like pushing through a toothpaste tub, you know. Cob is very, very complex, and it has a lot of pockets of air, and it has organic material. It's very anisotropic, you know. It behaves in different ways in different directions. So looking into that extrusion system was particularly challenging for us. And then, of course, using the large-scale robot at the University of Cardiff to look into how can we extrapolate these into larger scale constructive systems. That involved not just, of course, the testing of 3D printed sequences and 3D printed designs. How can we establish 3D printing patterns for such a complex material, but also a lot of hands-on work, a lot of low-cost extrusion system. As you can see from that image, that's a robot mounted with a plywood and 3D printed nozzle. Everything was very sort of low cost to begin with as a matter of testing, and some of that testing is reported in the paper that you can see referenced on the bottom left. And to be fair, a lot of that experimentation was conducted by colleagues at the Welsh School of Architecture through a vertical studio that ran for 2 years, where they were able to work with the architecture students testing this technology, as well as the design opportunities and design spaces that you could find through their robotic 3D printing of cob, right? In order to better inform this as well, all this material was sourced locally, and we'll get to those results in a bit, but it's quite difficult to characterize a material that is so complex, because obviously the properties of clay and soil and organic matter in different parts of the world can change greatly. Eventually, through the project of a PhD student from the University of Adelaide working with us, Mohammed, he did develop a dual canister extrusion system, which would allow us to print larger objects, as well as larger kind of building elements, and looking into things like the right mix, right? The right way to specify the ratios for different ingredients of the mix, like water content. And this was actually prototyped in actual kind of scale, and there were tests conducted around to what height can we get, and also to what level of structural soundness can we get before the model kind of collapses. So as part of this experimentation, we saw things like this, for example, some quite interesting opportunities in that sort of design area, reaching near or about 60 centimeters high for different building elements, which was really good at the time. As well as, of course, we haven't printed a building with this, but we did test 3D printed samples and the thermal performance of 3D printed samples against handmade samples, and we can see here in this graph in the three kind of middle triangles, let's say, those represent the conductivity values of 3D printed cob, which suggests that even though we have air cavities and we use less material, the conductivity, the thermal properties are actually quite similar to that of handmade solid cob samples, right? So if you want to have a look into the thermal performance assessment, there is also the reference here at the bottom left of this slide. Going back to, again, this diagram, just to show you a different project, I'm going to show you a second step after the COP 3D printing project, when we were approached by an industry partner funded also by the Southwest Creative Technology Network called Thomas Duggan. He runs a studio on product design and also experiments with different materials and robotic technologies to produce pieces of art, right, or products. So this was really, really interesting, because his area of practice was already in the arts and in the design sort of sector. But through this funding, we were able to engage in this collaboration through the provision of, from our end of the partnership, let's say, all the coding, right, and technical specifications and technical development of clay 3D printing trajectory planning and 3D printing sequences kind of overall. So this was an interesting project because it doesn't only sit in this middle sort of STEAM area, but actually expands that and actually has partners that address all these different components of our project delivery. So this was supported by Southwest Creative Technology Network, and from our end, we supported with all the robotic sort of coding and visual programming elements. This was the setup, but eventually we did bring a robot into our ceramics workshop for a long period of time, which allowed us to start testing and identifying the design and the coding challenges associated to clay extrusion and how clay could work in the context of Thomas Duggan's, creative practice, if you wish. This was all made in a visual coding environment called Grasshopper that some of you might be familiar with, using the Kuka PRC plugin and some bespoke electronic elements that we develop in the university. And of course, and what is really interesting is that this project allows us to revisit the concept of negotiation or craft-driven innovation, which we developed during the Competing Crafts project, because clay is very different from cob, obviously, but different types of clay are also very different between them. And this project was actually developed through a prototyping and iteration methodology where we had to find the right mixing ratios as well as the right robotic coding properties in order to successfully engage with processes of printing. So you could see a lot of little examples like this, which are small scale tests and iterations and prototypes with no purpose at all. This is not a cup. This is not anything really. It's just to try to find out how the material can inform a process of innovation delivery. So we made a lot of these things, failed tests, some successful ones, a lot of pattern testing, a lot of little small scale tests that would allow us to test the properties of the filament as well as the bonding between different layers, so we can better understand the material in the context of not just the production of random objects, but actually in the context of possibly scaling this up through countercrafting methodologies or looking into architectural or spatial, larger scale applications for these methodologies, which you will see in a second. At that point in time, we started generating more complex printing patterns in order to achieve a better height, in order to start testing the performance indicators of clay. And what we did was to expand the project through slightly more complex generative design approaches to 3D printing, as well as through material science approaches. So we partner up with a company called Imeris, which is a material development experience on clay and clay composites, and they did develop a material which is bespoke for clay 3D printing, which involves a mix between water and ethanol, right? And given this mix, ethanol evaporates quicker, and therefore the clay has a slightly better mechanical results when you print with it. So you can print larger objects without much deformation or collapse. At the same time, while we were having this quite technical conversation with them, we engaged with a couple of museums, among them the Tate in St. Ives, the Tate Museum for Modern Art, to exhibit this work. So it became this really interesting network of partners ranging across technical as well as artistic and creative, areas of work. And we ended up printing things like that. This is around 80 centimeters in clay, which is a lot. It was a quite kind of successful print, and you can actually see the remnants of the code, right, on certain walls and details of this 3D printed sort of texture, as well as acknowledging the failures. This is a collapsed model. However, we kept it in order to try to better understand why it collapsed, and we documented this process quite thoroughly. So what you can see on the screen is actually not a photography, is a 3D scanned model of a failed 3D printing example. At this point in time, Tom had the great opportunity of exhibiting this work at the Tate, where we were able to actually take the robot for a live 3D printing installation of large format clay objects. And after that, we have been focusing, of course, given the challenges of COVID, access to facilities is a bit of a challenge. So what we have done is to document these subjects on a digital format to try to outline the opportunities for users to engage with objects and artifacts remotely. So what we did was to scan this, and we managed to get a small grant with Plymouth Museum, the box, that's the name of the museum. And we did submit a small series of speculative images and models that look into the virtual aspects, right, of printing, looking into not just those textural and 3D modeling properties, how to better understand 3D printing, how to visualize that layering opportunity, but also how can we speculate a little bit into slightly more large format architectural spatial implications of 3D printing technology. So this was submitted a couple of weeks ago, and if you look into the Box website, there is already a small mention to it, but some of these documents these images, sorry, have not been released quite yet. And in that context, I'm gonna tell you a little bit about, this is the last topic, which is our master's program on integrated design, which captures this approach, if you wish, of kind of merging and exploring the intersections between technical development, prototyping, as well as design thinking and creative skills. That is actually the reason why the program has an MA and an MSc branch, right? So the MA branch deals with a bit more, let's say, arts and design content, whereas the MSc deals a bit more with technical development and engineering design aspects. However, it's a co-taught program. So the studio, in effect, is this pool of projects and students working on different projects in the digital sector. This program was approved earlier stages. This was a couple of years ago by a quite kind of prime team of external advisors that includes the Manufacturing Technology Center, but also Autodesk and the head of the Institute for Social Innovation in Birmingham, as well as the head of the Architectural Robotics Lab from Cardiff University, with whom we conducted the Computing Craft Research Project. Basically, what the program does is to provide a structure, a curriculum delivery to do things like what I just showed you, right? To start in this process of ideation and research, and then engaging with this with this process of prototyping, testing, and iteration, all the way up to production and scoping how something could be delivered to market, right? So that's actually our curriculum. We have a design studio that actually starts in that kind of ideation and research space, and then moves on into that prototyping testing stage during semester 2, supported by modules that either builds your skill set or exposes you to entrepreneurship and business skills, so you know what to do or how to engage with intellectual property or technology development, or how different businesses engage with that. This is an example session, a Lego kind of conceptualization workshop with Dr. Stukov from Salford University, which is part of a series of guests that we have in the course, and a series of projects that we have in the course, because again, this is very much student-led. So we have projects across a range of sectors, including computing, sensing, robotics, manufacturing, and so on. This is a wearables project that a student is delivering in partnership with the Tate in St. Ives. And this course is also co-taught with the MA in Smart Urban Futures, that addresses kind of the smart cities narrative, but also delivers technology from that in that same curricular sort of structure, right? That allows our students to engage with elements of data, AR, VR, the Internet of Things, and all those technologies which are a bit more aligned with the kind of smart cities, spatial placemaking sort of narrative. This is one example from that project. Is a student working on smart energy microgrids and voice interfaces for smart microgrids in the context of kind of clean energy problems. A series of industry guests. So our students are not just in the academic bubble, let's say. They actually do benefit from a range of companies that join us for guest lectures and workshops throughout the academic year. And actually, we have just announced on Instagram. You can see our Instagram handle on the left, by the way, if you want more information, our future lecture series, which will run this year. And we haven't announced the lineup of guests, but I can tell you that is really great. And we will be talking about some of the topics that you see on screen, including automation, fab labs, artificial intelligence, co-design, cities, and so on. So it's a quite fascinating lecture series and we're very happy and proud to present it. The last thing I'm going to mention is that our university was the recipient of an industrial strategy cultural development fund to develop the use of digital technologies to drive growth in the local economy. So our course actually benefits from this through the provision of studentships with local industry partners. This is a student running a workshop at the Tate in St. Ives in Cornwall. She's working with them under this studentship scheme. And what the studentship does is that it offers some money to cover fees, not all of the fees, but some of the fees, as well as some funding to support the project costs, typically used for materials and kind of consumables. And for this year, these are not all the projects, by the way, but there are some projects with some industry partners. And as you can see, those projects range between artificial intelligence, voice interfaces, virtual engineering, haptics, robotics, and so on. So it's a quite interesting set of projects that some of them are more, if you wish, architectural than others, but that multidisciplinary nature of the course is something really, really interesting to us. Said that, if you want more information, we do have a virtual open evening the 7th of October. You need to register for that, but the link is available through our social media handles. So with that, I finish my presentation, and thank you very much, everyone, for listening.
Thank you, Dr. Alejandro. It was really a very wonderful presentation, and I should say it is a mixture, a blend of, like say, craft work and electronics, like robotics, all put together beautifully. You have presented, and it was quite interesting. Basically, from my engineering background, I was also very much interested to know things like engineering can do to architecture, and what are the works you are doing. Now, let me transfer it to Professor Balsava sir, so that he can take it forward. And anybody is having any queries, you can please ask till Professor Balsava sir can comes in. Yeah, sir is there. Yeah. So it is not audible. It is not audible. Yeah. No, still we could not hear you, sir. No, sir. I don't know. Dr. Alexander.
Do I need to do anything?
Is it audible now?
Yeah, now it is audible.
Yes.
Now it is
Yes.
audible. Yeah.
Okay. So in the present context, I find that this is particularly becoming more significant and relevant because of various issues. One is the fact that the entire act of construction itself now needs to shift in a certain way, which has to be more technological in nature. The reason being that we need to, I think if these norms of social distancing become the new normal as everyone is discussing, then I think that itself is opening up new questions on how do we construct, and how do we make. Another very real issue that's coming up, I agree, appears far-fetched to us, is the manner in which architects like Norman Foster are now imagining spaces on the moon or on Mars. And I think these are all, we're ready to colonize other planets, it appears. So I think this kind of technology becomes a fascinating bridge to also in conservation. It's come into use in India as well, where they need a very high level of precision, and this issue of translating craft into a certain technological interface, or digital interface. I think in India we have a large scope or a huge potential to work in that area because many of these crafts are dying out, or many of these crafts need a precision which does not exist today. or many of these crafts are this entire act of construction happens in very dangerous conditions. So when it happens, I mean, like the Notre Dame rebuilding is definitely a very dangerous condition. In medieval times, I think kings could have their slaves hanging from roofs to construct, but I don't think in modern times we can even afford that. And so that's why this, at a sociological level, I'm just looking at this whole act in its social relevance, and I find that it has become more and more significant. Having said that, I'm curious to know, and again, there was a range. There was a range of translation of digital into virtual images for like the ones you showed on density and the studies of the city, and so there is one kind of a path that travels in that zone. There's another path which is an interface between the digital and the act of construction itself, which means there's a materiality to it, like a 3D printing, and so there is a material conversation, but that conversation can open up into so many other newer ways, as your presentation has wonderfully displayed. That there are, and it can be also ancient materials, so that it doesn't mean that you have to have a state of art ceramic, or one is looking at hay and one is looking at husk and one is looking at, in India, of course, one material is rice husk, which has not been used, but which is wasted in a large quantity. So I think from a sustainability point and recycling also there are. So my curiosity is, do these 3 or 4 paths, do they have a conversation among themselves, or right now are they 3 parallel paths? I mean, that was one question that has come up. And because there's one which is highly virtual, there's one which is very has that embodied experience with robo, and it can go up to art. The robo and art is, of course, a very controversial area, but has, I think, a huge potential for exploration. And the other is this kind of mapping and data analysis, the smart city. Now, is there a conversation in these 3 paths, or do they run parallel to one another?
Yeah, I think that I think there is. So of course, what I've shown here are just extracts of larger, kind of agendas, and I think that what we have tried to do over time is to provide those approaches, if you wish, with a slightly more critical background and sometimes a theoretical background, to better understand how that sits, how automation is not just about the use of the machines, but it's a profoundly social and cultural shifting process. And for example, when we published the paper on negotiated matter on craft-driven innovation, actually our background for that paper is research on vernacular architecture, as well as research on tectonics. What technologies as well as cultural significance means in the context of kind of tectonics as a concept, right? So we have been trying to look into some of those questions, as well as a really good example to illustrate that is the jobs automation discourse. When we get asked, well, you're replacing potters because you're printing with clay now, or you are replacing craftsmen because and I don't think it's that, really. I think it's part of a trajectory of innovation rather than a replacement agenda.
I think I completely agree with you. If I can just qualify what you were saying, in India there are states like Rajasthan and in North India, Northwest India, where the traditional craftsman has actually appropriated the technology. It's not like the presentation that generally happens is high technology appropriates the vernacular to learn and do, which is very different from the traditional craftsman appropriating this technology. And in India, there are many cases where the next generation of craftsmen have actually appropriated this tech. We could send you some of the examples that we've documented in our university, where the younger generation today of craftsmen is appropriating some really state of art digital printing, and then they really nuance the digital printing with the handmade on the digital printing. So it's a very blended kind of
Yep.
new kind of approach, and I think it has huge potential. Right now, maybe it's more in the research laboratory in most universities, but there are pockets of communities, especially the stone making community and several other metal community in India, who have been blending this combination from, I would say, the almost last 5 years now. And I think this, if they were to be exposed or could meet y'all, and I think it can open up completely another dimension, because y'all would, as you rightly put it, that approach may have an absence of critical thinking, or that approach may be more a hands-on immersive experience, whereas what y'all are bringing into it is a combination of critical thinking, systemic approach, and an interface of materiality and culture, and that kind of lends itself to so many other kinds of expressions, and I think there was another question that has been asked, and that question is, can these systems be used to simulate a reality, in even in terms of its structural safety?
Well, I mean, there are structural simulation tools out there which can be used, I guess, in virtual reality simulation, immersive environments, if you wish.
Yes.
I think that what is interesting is that some of these technologies have different roles as a design process evolves. So if you want to design something, but you're still testing what are those design considerations, right? And you're still looking into what are the key research concepts that you need to follow in that kind of development process. Of course, I think technology offers a rich groundwork of opportunities there because it can facilitate prototyping tremendously.
Sure.
In the design space, particularly when it comes to larger structures, I have found, and this relates a little bit to a question that is on the chat window at the moment about the design
Yes.
thinking process as well.
Yes. Yes.
I have found over time that there is a lot of sometimes digital tools are interpreted because of from a perspective of their representational potential. I
Sure.
can use digital media to better represent design intent. And I think there is a difference between that communication graphics potential and the contribution that those tools can do to a design process, right? In my studio, we had
Absolutely.
endless discussions with students around, you don't have to make a digital render all the time. You need to use
Absolutely.
technology in an interesting way that informs and helps you eventually design better buildings, right?
No, absolutely, because that is the risk of the digital, virtual, and the visual versus informing something that is linked to the act of building, and informing something that is linked to the act of how a form is made. And I think what can happen is we see a lot of cases where one gets carried away with the visual, and whereas the experiments that you all are doing at Plymouth is something more tangible, something more immersive, something that has a relationship to materiality. And hence I was curious to know how do these three kind of converse with one another in your processes, and I think it's an interesting, if there are few more questions, Sandhya or Sri or anyone, please.
There is one question in the chat. Like Sri Venkatesh.
Yeah, Sri, could you
So
read it out?
the question
No,
is
Sri
like,
is here. No, Sri is here. Sri, could you read it out, please? You could speak. It would be nice.
Yes, sir. Good day, sir.
Yeah.
Can you hear me?
Yes.
Yes, sir. Good day. I just have a question.
Yeah, please go ahead.
What are the learning effects of hands-on activities with the digital technologies in the design thinking process, with particularly with respect to first year students and second year also?
Well, that's a big question, particularly because design is fairly complex. I did so a project that I haven't mentioned here is my doctoral research, which looked into the design studio learning process and the design process mediated and supported by augmented reality. So what we did in effect was to overlap, right, digital data on physical models. So we actually tried to study and explore the interface, right, between that digital realm, if you wish, and that thinking design kind of conversation process. So I actually use a methodology using video documentation of design tutorials to try to better understand how these models either facilitate or shift, right, or engage in a process of design and design learning. That was made with an undergraduate architecture program based in Italy, actually. I'm happy to send you more information about that research, by the way. If you send me an email, please do, and I can send you more information. But as a summary of the findings, something that we found tremendously useful is that usually there is an approach to technologies in design studios that relies a lot on the tool itself, the software, the troubleshooting. We cannot use this, or this is difficult, or students need to learn this or that. And students are tremendously flexible and tremendously, talented young people that are very good at using technology in many different ways. So what we actually found is that troubleshooting is a quite small component of a more complex assembly of situations that take place in the design studio. And also we identified that a lot of that learning process and a lot of that design interaction happens not necessarily as a result of a conversation with a tutor, but as a result of just self-driven curiosity. Like, I want to test this and see where I get. And that element of uncertainty and risk, if you wish, seems to be quite key component of the student's learning experience as well. So to kind of summarize some of those findings, I would probably say that there isn't, and for students now probably who have typically quite substantial digital identities, I would say, there is a little divide, or it's quite difficult to establish a divide between what constitutes design thinking through physical models or digital technologies. Is digital technologies are part of their toolkit in the same way the drawing board is, or the set of pens are, really. I would probably say that those lines are quite kind of blurry at the moment, and they are probably due to become even more blurry now during COVID times, where a lot of the delivery will take place through online or digital media, and we will have to look into how those processes of learning can be better supported, given the lack of sometimes that physical kind of interaction. So that's what I would say about that question, really. But that's a quite deep topic for me, because I spent 4 years working on that. But if you drop me a line, please do so, and I will be happy to send you more information on that.
Thank you. Are there any more questions? Sandhya, would you like to ask? Or
I would like to ask a question, Professor Alejandro. It was a wonderful presentation.
Thank you.
And I think because what happens over there is it's like limitation. There is no limitation for imagination, or there is no limitation for creativity. And the tools are also helping us to do what is there in our mind. But still, I find that what is the kind of drawbacks, or what are the kinds of deadlines which we have to really work in this particular tool, so that we are getting or achieving the expected kind of results.
If I understood the question right, it was related to the challenges or limitations to the use of certain technologies in design contexts. Is that okay? Is that correct?
Correct.
Yeah. I mean, there are lots. I think architecture is my work has benefited a lot from multidisciplinary work with areas such as computing or manufacturing, which have a tendency to adopt technology much more quickly than architecture and construction. You can see some buildings are still being built the same way as 100 years ago, really. And some, which is not a bad thing, but that hints at the fact that our discipline and our professional area is typically a bit slower than others on adopting technology. For example, the concept of BIM, building information modeling, was actually suggested for the first time in research contexts in 1978. In 20 in 2004, I think, research in doesn't really have to sectors that they with valid and interesting kind of digital frameworks. Another challenge on that has to do with funding, and I don't mean funding only from a wealth or money perspective, but it's quite easy to see how certain narratives of automation or the use of technology has been primarily developed in universities or institutions which are at the center of certain economic or social discourses. So you can see wealthy universities developing big things with big robots and organizing their conferences, and there's nothing wrong with that, really. But there is clearly a periphery, if you wish. There is clearly a matter of innovation taking place in other parts of the world, sometimes under conditions of scarcity or innovation driven by other needs, that sometimes I would say are not always acknowledged, as part of these institutionalized kind of research narratives. And I think that's an interesting question to crack, actually, because I think it makes a disservice to a range of areas and geographies and cartographies of innovation happening all around the world by other institutions as well. So I think there is an element of centrality and peripheries as well on the way innovation happens in the academic world. And I think that's a challenge when it comes to the adoption and delivery of digital solutions as well.
Thank you for that kind explanation.
You're very welcome. I cannot see any more questions in the chat, so I'm not sure what to.
No, maybe there's Dr. Jyoti ma'am, if you'd like, we can sum the talk for now. Or if there are a few more questions that someone has, we could raise it. If Sri or someone else has some questions.
Yes,
Sandhya?
I got Sandhya here. Yes,
Sandhya.
I have a question. Sir, I have heard about 4D printing as well, 3D. Is it this one and the same thing, or is it something different? That's my question.
Thank you. I'm not sure what 4D printing is, to be honest. I don't know. I can search it and get back to you on that. Presumably, in my additional features to standard 3D printing that might have to do with certain elements of additional properties to what that 3D print could do, let's say. But I don't know that as a concept, if you know what I mean. some areas of 3D printing that will be looking either different materials or to bespoke printing sequence to the use of robotics. And as far as I'm aware, none of them fit within I haven't really seen the concept of 4D. I'd have to get back to you on that question, if that's okay.
Yes, thank you.
Thank you, Professor. I think there are for now no more. I think for now there are no more questions, but we hope that we can continue this dialogue in various other forms, and we will also maybe share with you the several experiences that we have documented here, this relationship between craft and but
Yes, please.
appropriated by the craft communities, not appropriated by university fab labs, you know. So there is another kind of mirroring or of this whole process which becomes very interesting. So I think the talk has provoked a lot of other thoughts which we can look at. And we do, as Dr. Deepak suggested, we do look forward to a collaboration and how it unfolds. Hope that the lockdown happens quickly so we can even invite you down to India at some point in time. And I think that's we'll continue this dialogue. I would invite Dr. Jyoti Lakshmi now to sum the evening, and and I think this is really the beginning of a conversation rather than the end of a talk, and I think we'll look forward to it. Thank you, Dr. Alejandro.
Thank you very much, and thank you very much again for the invitation, and looking forward to continue this conversation with you.
I'll invite Dr. Jyoti Lakshmi now. She's to kind of sum up the evening, and then we could close.
Thank you.
Good evening, Professor Alejandro. It was a wonderful presentation, and I found that with this pandemic time, with the lockdown, I think we are more connected and more technologically connected than otherwise. So this is also like an eye opener for all the students, and it is opened multidisciplinary various disciplines coming into picture. And the first time even I was also so surprised that the robotics and engineering, mathematical models, architecture, creativity, innovation, all coming under one kind of a talk together. And I think our students would have been really, it was a real kind of eye opener for everyone, because they can also cope up into a different kind of a stream altogether and practice. There is no limitation of any kind of restrictions of creativity, or they should not feel like, okay, whether it is possible or not possible, because I think everything is possible if you have a will and if you have an idea and if you have a creative mind. I think everything is possible, and you can very well do it as a prototype, and then you can actually do the experiment prototype, and then you can make it as a product and successfully launch it for the public. The other one which was very interesting in your talk was the smart city, where we can use the technology for placemaking. So that is another kind of a vast area where all of us can really work on, because many cities we know that the placemaking is becoming very, very important. And right now, actually speaking, we have really understood the importance of place and the placemaking techniques to be with nature and with the place over there. So for that also, all the technology is going to come together and help us. Is a great kind of an eye opener for everybody. And I'm sure that as our dean was still talking about, after this lockdown, we are more excited and enthusiastic to work and really work on some projects in which we will be able to collaborate, and our students and your students can come over here, our students can come over there, and do a kind of an exchange program and more exposure of our local vernacular architecture, our city spaces, and your areas can be like a kind of dialogue, which is very, very important right now. And thanks for the opportunity and for the wonderful presentation. Looking forward for further collaborative workshops and talk series. And we will definitely register for this virtual opening evening on 7th October. Definitely will participate from Saveetha College of Architecture and Design. I'm very happy, and thank you, Deepak sir, for coordinating this talk, and thanks all the participants and students and faculty members and whoever is watching. Thanks a lot.
Yeah, thank you, ma'am. Thank you, Dr. Alejandro.
Thank you very much again for the invitation, and looking forward to keep talking to you. And thank you for everyone.